All right, ladies and gentlemen, here we go. Continuing with our solving systems, but this time we're going to be talking about what is called the elimination method. And this method is really good when you have both of your equations in standard form. That means when x and y are on the same side. So for example, something like 2x plus 3y equals 6 and 3x plus 4y equals 15. Something like that, meaning both variables are on the left side. So when we look at it, we're going to notice that there's one variable, x or y, that we're going to be able to eliminate a little bit easier. And we want two things to be able to do that. We want the same digit and opposite signs, because a 4x and a negative 4x, that just zeroes out. That gives us no x's at all. So it says change the equations if necessary to do elimination by adding. So for your homework today, you're going to focus on changing one equation, and then next week you're going to focus on changing both equations. Once you have the equations changed, we're going to solve for our first variable, then we're going to solve for our second variable, and then again, that check is very helpful. Not really required, but it's very helpful, especially if you're needing those as many points as you can for your assessments. All right, so let's see here. So again, we want two things, same digit, opposite sign. So if you notice, there's little ones in front of the x's, but both x's are positive, where the y's are opposite. So therefore, I can eliminate the y's because I want same digit, opposite sign. So really, I can just put a nice plus sign there. I have 1x plus 1x, which is a 2x. The variable y's disappear, 1y and negative 1y cancels out, and 14 plus 4 is just a simple 18. If I divide by 2, like it's ready for me, then I find x is equal to 9. So there we go. I got my first part of the answer, but remember, it's like when we're graphing, so we're still looking for that point of intersection in mind. So it means I need to find my second answer, which is the y value. I can take either equation if I'd like to. You really just got to decide which one's best for you. And usually, students will pick the ones with the most positives. So by default, I'm going to go ahead and take the first equation because they're both positive. If my x is 9, what is my y going to be? Well, some of you can probably just do your mental math, or you subtract 9 both sides, so y is 5. So I go ahead and write my answer as an ordered pair. So you're going to notice once we get it to the solving part, it's really similar to what we've already done. The only thing that's really different is trying to figure out how the x's, or in this case, the y's, eliminate. So let's try, before we do that, let's check it. So again, x plus y, that's 9 plus 5. X subtract y, that's 9 subtract 5. Both of them need to check out, and if they do, that's your answer. Remember, if the video is going a little fast, you can pause it. All right, we want same digit, opposite signs. So if you notice, the x's are definitely the same digit, but they're not the opposite signs. The y's, they're not even the same digit, and they're not even the opposite sign. So that means we're going to focus on the x's to eliminate. But in order for them to eliminate, we have to have opposite signs. So the little trick is, or actual work is, to go ahead and change this whole equation multiplying by -1. Because if I multiply by -1, using my distributive property, the 3x would now become a -3x. So let's go ahead and show some arrows here. I'm going to bring my first equation over to the right, and the second equation, everything multiplies by -1, which means my 3x becomes -3x, my positive 1y becomes -1y, and my positive 7 becomes -7. Now it looks like example A, where my x's are same digit, opposite sign. So I'm going to go ahead and use addition. And if I do that, so my addition sign didn't show up, so I'm going to go ahead and write it there for us. 3x and -3x eliminates. It's gone. 2y subtract 1y, that's 1y, or just y is equal to, and 2 plus -7 is -5. Excellent. So I got my first half of my answer. Now, whenever you change an equation, you cannot use one of the new equations. You got to use the original. So whatever's in the textbook or on the worksheet. So you can pick the first one or the second one. Really doesn't matter, but if you notice, since you got a little 1 here in front of the y, that's slightly easier than a 2y, but really doesn't matter. So for example, if I take the 2y, I just do a little bit of multiplication. 2 times negative 5 is a negative 10. And now you got a really nice two-step equation. Add 10 both sides. Divide by 3 both sides. X is 4. So I think my answer is 4, negative 5. And then again, if I wanted to check, I would plug in those numbers for the X and Y location. And I have to work out for both of them. Excuse me. All right, example C. So let's see here. Same digit, opposite sign. So a 6 and a 3, they can both become a 6. A hidden 1 and a 2 can both become a 2. So really, either one I'd have to multiply by 2, right? Because 3 times 2 is 6, 1 times 2 is 2. But that does not take into consideration that I want the opposite sign. I would like the 3x to become a negative 6x, or I would like the 1y to become a negative 2y. So what I'm going to suggest we do is multiply the bottom equation to get the x's to eliminate. The x's need to be a 6, like it shows up there, but really I want a negative 6x. Excuse me. So great news again is the first equation gets to stay the same. So I'm just going to bring it over. Second equation, let's multiply by negative 2. So the 3x becomes a negative 6x. The 2y becomes negative 4y. And then this 9 here, that's actually the one that the students forget the most. That also has to multiply by negative 2. So that's going to give me a negative 18. If we'd like to, we can go ahead and put a little 1 there. Since the x's are same digit, opposite sign, I'm able to use addition. Because when I add them up, the x's eliminate. So look at my y's. I get a negative 3y, and the integers on the right gives me a negative 12. When I divide, being careful with the negative signs, I find y is equal to 4. Now that I have my first answer, I'm going to go back to the original equations, pick one of those equations to solve for the other answer, or x. Remember, it doesn't matter which one you choose. Let's try the first one. Remember, it's 1y, or y is 4. So I'm going to subtract 4. If you want, you can put a little 1 there. And 1 times 4 is 4. Subtract 4. Ooh, I think this is going to give me a fractional answer. 2 and 6 can both divide by 2, so it gives me 1/3. And our ordered pair, remember, x is first, y is second. If you wanted to check it, again, 3 times 1/3, that would just cross cancel to become a nice 1. 2 times 4 is 8. 1 plus 8 is 9. Looking pretty good. Okay, so let's make a choice. Do we want to eliminate the x's or the y's? They have to become the same digit, opposite signs. So let's see, a 4 and a 3 can both become a 12. A negative 2 and a negative 1 can both become, or a 2 and 1 can both become a 2. So I think we're going to eliminate the y's, because if I wanted to eliminate the x's, I would have to change both equations. But if I can eliminate the y's, I really just need this negative 1 to become a positive 2. So it just so happens, again, that I'm going to multiply by negative 2. It's not always that. It's just whatever value you need, you're going to multiply by a number to make it that. So I needed a positive 2y, so I have to multiply by negative 2. Again, first equation stays the same, just bring it over. Second equation, distributive property. Negative 2 times 3x is negative 6x. Negative 2 times negative 1y is positive 2y. And don't forget this last one. Negative 2 times 12 is negative 24. Using addition, the y's eliminate again. 4x and negative 6x gives me negative 2x. 10 and negative 24 gives me negative 14. Divide, very similar to the previous problem, x is 7. All right, now we're at the choice. I'm going to get some orange vanilla flavor. Sorry. Refreshing. All right, pick one of the equations. If you notice, they're somewhat similar. 4x and 3x. Let me change it to the pointer. Pretty similar. Negative 2 and negative 1, pretty similar. 10 and 12, pretty similar. So it's not really clear which one is better than the other. Now remember, if there's more positives, then we definitely want to use that one. But in this case, they're about the same, so it really doesn't matter. All right, x is 7, so I'm going to substitute it. 4 times 7, 28. Solving equations, subtract 28 both sides. 10 subtract 28 is negative 18. Divide by negative 2, y is 9. Remember, x, then y. Excellent, excellent. All right, so that's changing one equation. We are going to go ahead and finish our notes with changing 2 equations because we're going to do day 2 on Monday, and that's a shorter day. So we want to get the notes completed now because it's a longer day. And then Monday, we'll just do some homework out. All right, so keep in mind, we want same digit, opposite signs. So looking at the x's, 4 and 3 can both become a 12. 5 and 2 can both become a 10. 12 and 10 is pretty close to each other. But if you notice, the y's are already opposite signs. So let's eliminate the y's. Now, if I want to eliminate the y's, they both have to become a 10. So I want a negative 10y at the top and a positive 10y at the bottom. So I'm going to go ahead and put brackets around both. And if I multiply by 2 for the first equation, I get that negative 10y. And multiply by 5 on the second equation, I get my positive 10y. So both equations have to change. First equation, 2 times 4x is 8x. 2 times negative 5y is negative 10y, and 2 times 3 is 6. Don't forget that last multiplication. 5 times 3x is 15x. 5 times 2y is 10y, and 5 times negative 15 is negative 75. All right, so you should have this. I'll give you a moment to write it down. The y's eliminate again. It's not always the y's, though. Sometimes the x's eliminate. So 8x plus 15x is 23x. Notice how I leave a little space here where the y's would go. And then 6 subtracts 75. All right, divide by 23. So x is equal to negative 3. Now we need to make our choice on which which equation we want to use to find the y. So again, 4 and 3. Pretty similar. Negative 5 and 2. I might like that 2 because it's positive. 3 and negative 15. So it's kind of like opposite signs, opposite signs. Let's see. Let's choose. I like a positive y. I think that's a little easier. But it really doesn't matter, right? So x is negative 3. So I've got 3 times negative 3, which is negative 9. Remember, you can always pause the video. Add 9. 2y is equal to negative 6, so that means y is negative 3. Again, the solving equations, what we did back in August, what you did in 7th grade, maybe even a little bit of 6th grade. My kids, my boys, they're 7 and 8. They're doing really basic solving equations like 4 plus x equals 6. So what is x? Well, 4 plus 2 is 6, right? A lot of basic mental math, younger ages. More advanced as you get older. My oldest son, who's 14, is solving some really crazy equations for high school math. But again, based off of 6th grade, 7th grade, 8th grade. All right, one more, I think. Similar question. What can the A's become? A 2 and a 5 can become a 10. 3 and a 4 can become a 12. So even though 10 might be a little bit better than 12, we notice that the B's are opposite signs. And we like that because we want same digit, opposite signs. So I'm going to multiply. That one gives me a 12. Arrows. 4 times 2a is 8a. 4 times 3 is 12b. 4 times 35. Well, 4 times 30 is 120. 4 times 5 is 20. So I think it's 140, right? 3 times 5a is 15a. 3 times negative 4b is negative 12b. And 3 times 7 is 21. Use addition. That's what our whole goal is, to get it to an addition problem. All right, B's eliminate. 23a equals 161. So that means a is 7. Pick an equation. Hopefully you notice that the first equation, everything is positive, but you could use the second equation if you wanted to. Two times 7, 14. 3b equals 21, so b is 7. Remember, alphabetical order, so A goes first. Oh, but you know what? They're exactly the same. Even better. 7, 7. Yeah. Same values is nice, but not always going to be the answer. All right, so when you're done taking your notes again, you're going to do a little bit of homework help. Being awesome. We're going to focus on day 1, primarily just changing 1 equation. Day 2, changing 2 equations. And day 2 is going to be next week. All right. Be awesome.